So I have a 4-volt source over here, a 3 ohm resistor, and then I have a control voltage source, 3Ix, and then I have Ix. And then I have a 4 ohm resistor here. And then I have 1 ohm resistor here. And when you do the node voltage method, okay, if you do the node voltage method, the first task is to assign node voltages. Okay, I think I got everything right, and this is 4 ohms. So you go through the first task. Give this voltage V1, give this voltage V2, and give this voltage V3. Okay? And then assume that this is grounded so that it is always at 0 volt. And the next thing you should do is actually try to connect these voltages to each other by any values that you should have. This is 0 volts. Okay, 0 volts. At ground over here. And this is what is called a super node. Okay, this is called a super node. Why is it called a super node? Because a voltage source is like a short circuit other than a voltage drop across it. So it is as if these two are connected by a piece of wire, but it has a voltage drop across it. Okay? So we should consolidate this node into a super node and say that V2 is just equal to V1 plus 4. So V2 and V1 are joined in the hip, just like this one over here. Okay, they're tied to each other. They cannot be different from each other. Once you know V1, you know V2. So we consolidate these two unknowns. And then there's another one over here, okay? And it's quite easy to figure out that V3 must be 3Ix because there's a voltage control, current control voltage source over there. Okay? So right now if you look at this problem, you only have two unknowns, Ix and V2 to find, right? There's no other unknowns that you need to find now. Just that two unknowns. V1 is dependent on V2. Okay, V3 is dependent on Ix. So you just need to find a place to write a KCL. In the node voltage method, you have to write KCL. So let's find a place to write KCL. Okay. So let's write KCL somewhere over here. Okay, or over here, doesn't matter. Okay, so the current that flows in here is Ix, the current that flows in there must be Ix, the current that flows in there must also be Ix. Okay? So it says that Ix is equal to minus V1 over 1 ohm, okay, is this voltage drop in this direction, which is 0 minus V1, V1 over 1 ohm, okay, And then if I write the value for KCL over here, it says that Ix must also be equal to the voltage drop across here divided by that. So it's also equal to V2 minus V3 over 3 ohms. Okay? But V3 is equal to 3Ix, and I think that's what confuses most people. Okay, V3 is 3Ix, so it's V2 minus 3Ix over 3. Okay? So I have how many equations now? V1, V2, Ix. I would have one equation. Okay. Two equations, if I make this equal to Ix. And then three equations. Okay, I have three equations over there. Then I can use that to find V1, V2, and V3. Let me see, am I missing one equation?
V3 is English, right?
V3 is equal to 3Ix. That's right, I have this equation over here. Okay, 1, 2, 3, 4. And then 1, 2, 3, 4. 4 equations and 4 unknowns. Okay, and I can solve for that 4 unknowns quite easily. Or I can think of it as a supernode. I can actually write the fact that the current that goes in here must be the current that leaves this node, and write a KCL for this node also, and get one of these equations. Okay, if you don't want to think about KCL and supernodes, that's fine. You won't do anything wrong. Okay, but if you want to take shortcuts and want to write the equation down immediately instead of me doing it 3 times over, you can write an equation for this node right away. Yes.
Homework is due today.
It doesn't matter.
Homework is due today.
Any current can go to it. The current can be any direction.